Hello everyone. Today we're going to talk about the wiring for the remote control go-kart. Last video I did a quick walk around of the go-kart and pointed out some of the components and did a short test drive to demonstrate that it works. So if you haven't seen that video, you should go check out that demonstration video. I'm going to create this as a small playlist, so that should be the first video in the playlist. And then this second video, I decided I would cover the wiring and the components side of this thing, just to give an overview of what I did there. So I made a few drawings that we'll go through today to look at. Next video, we'll probably start the Python code and how that part functions. And so we'll start first with the kind of overview drawing I have here, just to remind everyone of the overview of how this go-kart functions, because that might help understand the wiring part a little bit better. So on the go-kart itself, which is this box here, we have the Raspberry Pi 4, which I call the Pi server. It runs a Python script that runs at boot. We got the Arduino with an Ethernet shield. It's an Arduino Mega. And then we've got the wireless radio that is on there. And so the Arduino and the Raspberry Pi are both connected to the radio via an Ethernet cable, network cable. So the radio also acts as a network switch for these two to directly talk to each other. And so the Raspberry Pi sends data to the Arduino over UDP, and that's how it sends commands to the Arduino. And the Arduino has the linear actuator for the steering, the servo for the throttle, the relays for the kill switch, and that wired up to it so that it can control the go-kart. If for some reason communication was to be lost between the Arduino and the Pi, the Arduino would stop, take the throttle to idle and shut off the engine. And so you can either connect the Xbox controller directly to the Pi and drive it without the need for wireless. Or if you want the wireless and drive it remotely, you'll just need the bridge connection, and then a client running the Python client script. Could be another Raspberry Pi, could be a laptop that you have the Xbox controller plugged into and sends the commands to the Raspberry Pi that's on the go-kart. And so that was the quick reminder for how the go-kart functions. Next, we'll look at the power wiring here. So this is how all the components get their power on the go-kart. This doesn't show all the control wiring. I've got separate drawings to kind of show how the kill switch works and everything. But this shows you how it all gets back to the 12 volts and wires up. So I'm just going to quickly walk through the drawings here to show how it all is connected together. So as I pointed out last video, we've got our 12 volt battery that powers everything, right? So that's the battery here, and it's got the connection to the ignition switch, which is here, and a connection to the relay here that provides power to everything. So we'll take a closer look here at the relay. So there's the relay there for a closer look. And then in the control box here, we've got the 12 volt terminal block. So the relay 12 volts comes in and the ground connection comes in, and all connects to this terminal block. So you can wire in and get to 12 volts inside the box. So, and then for the ground, you need a good common ground for everything. So I'm grounding everything to this clamp here to ground down to the go-kart. With the paint and with some of the rust of this old go-karts and everything, like with the engine and the kill switch, needed to run the ground up here and make sure everything was grounded because it wasn't making good connection towards the back of the go-kart. So there is kind of the grounds and stuff there. So let me close this one and come back here. So the key switch, it's got 5 pins. We're only using 3 of them. So the green green here are the pins that the wiring goes to. Try to label them like they're labeled either on the device or to make it obvious. So we got ground, and then we've got our 12 volt in. And when the key switch is flipped to the on position, it provides a constant 12 volt out here, which comes into our signal pin, which closes the relay and then enables us to get 12 volts out to the rest of the components. For the Arduino, we've got this 12 volt, 9 volt regulator. So it connects the 12 volts in and then 9 volts out to the VIN pin that is on the Arduino. So fairly straightforward wiring there. And then for the Raspberry Pi, another regulator. This one happens to be adjustable, so you can adjust it with a little screw. You need to get 12 volts in, and then the Pi takes about 5 volts. So I'm using it to the USB-C connector. You could use the GPIO expansion header, but that bypasses the regulator and fuse and stuff that's on the Pi. So a little bit better, I think, to just wire it into the USB-C itself. And you can get little USB-C cables with just the 2 wires that you can wire right in, and they're very cheap. So that's the way I wired up the Raspberry Pi there. And I'll show you real quick. I mean, here's an example of one of the step-down regulator converters that I'm using. You just got an in. This one takes an 8 to 22 volts in, and then a voltage out, so that you can adjust the range for. And that's been working for me fairly well. So the kill switch module is a 4-channel relay. We're only using 2 of them at the moment, but it's 12 volts, so we can take it direct to the 12 volt to be able to close and open the relay. And of course, grounded it. So I'm using relay 2 and 3 that's on there, or channel 2 and 3, depending on how you want to call it. So you need to ground those 2 channels as well. The servo for like controlling the throttle, I mean, it's just a simple servo, right? But we need 5 to 7 volts in. Originally, I had this connected to the same 5 volt regulator here. Might could go back to that. I was having just a couple little issues. I thought maybe that had something to do with it. So I moved it out to a 7 volt regulator. And things have been working and stuff, but that might not have been my initial problem. So, but I'm just going to leave it this way. So 12 volt in, 7 volt out, and of course everything grounded. And then the motor driver, this actuator is a 12 volt actuator and can draw, I think, the max up to 14 amps. And so a lot of the motor drivers and stuff for Arduino tend to be around 10 amps, but this one can go much higher. And we bring our 12 volts in and our ground connection that will be used to control the actual actuator motor. And then here are our signal pins that we need to connect 5 volts and then our ground. And so I'm going to flip over to this motor driver picture. And here are those pins that we need the 5 volts. So we need 5 volts to VCC, our ground connection. We don't use these pins. These are enable pins to enable the PWM pins, right, left, or reverse, forward, reverse of the motor. So we're always going to want to have those enabled. So I just take them directly to the 5 volts, so they're enabled. And then when we get to the wiring up of this, we'll see the PWM pins. And then 12 volt coming into our pins here. One side is for the incoming 12 volts, and the other side's for the motor or the actuator in this case. And I'll just point out here, there's the driver in my setup. Last but not least, for the power, we've got the wireless bridge. So the radio is just a 12 volt radio, so it can connect directly to the 12 volts. So that shows how everything gets its power. I'm going to pull up the kill switch next. So I'll bring that over here. So this is connected, as I pointed out last video, the kill switch is the only thing really connected to both the Pi and the Arduino. More for a safety thing. I consider the kill switch our fallback safety mechanism for shutting everything off, right? So I wanted to connect it to both in case Python script freezes up on the Pi, or if something happens to Arduino or something. There's two ways to do it. And so on the 4-channel relay, we're using relay 2 or channel 2 and relay 3, or channel 3. And so we have our trigger pins. The second trigger pin is to the pin 11, or that's GPIO number 17, depending on how you want to do your Pi numbering on the Pi board. And then trigger 3 to the 49 pin on the Arduino. Again, we have our grounds and our 12 volt coming in. So the engine kill switch works is on the engine itself, and I'll pull up real quick that. So the engine is a Predator 212 engine, already has the kill switch installed on it. And this is a ground connection, and then it's got a connection to the engine coil. And when you flip that off, it actually connects to ground and grounds out the engine coil to shut the engine off. And so we're just going to wire into that engine coil side here. Here's the wires coming in from the relays. We're going to wire into there. That way we can close out and connect it to ground and ground it out there. So really all we're doing with these relays is closing and opening the ground connection for this to be able to shut the engine off. I will point out, while I'm just on this picture, this is the oil sensor that's also connected into this when you buy the engine, and can shut off the engine if the oil gets too low. Driving around with a vibration like this and the go-kart bouncing around, it might sometimes falsely shut off. So just make sure you have oil in it, and I disconnected this sensor. But you see I've connected this engine coil wire to the normally closed contactor, meaning if go-kart doesn't have power or you flip the key switch off, it'll actually shut the engine off along with it, because the pins will close and everything will be grounded. So the Arduino and the Raspberry Pi have to actually send the signal to open the relay and therefore close the normally open pins. And so that would open these up, and you'd be able to start the engine. Here's the actual kill switch on the engine. So when it's flipped off, this closes and grounds out. Hopefully that makes sense. Next, we'll look at the actuator. So we pull that up. And I'll flip over here just to show a picture. If I can find it. Here's our actuator, right? And so by extending and retracting, we're basically just pulling. We got it connected to the steering rods here, and basically pulling left and right. And I disconnected the original steering rod there. That goes to the steering wheel. So motor driver, we've already talked about the power components of this, wired up to our 12 volts and to our ground. And then the RPWM and the LPWM, I have wired to pins 9 and 11 on the Arduino. And the 12 volt actuator is wired into the M positive and M negative side of the driver, right? So by sending PWM signals on these pins here, we can actually control speed and direction of the actuator motor. So that's how that works. And of course, we'll talk more about that when we get to Python and Arduino code later in the series. But pretty simple from an actual wiring perspective. Next, I'll look at the servo. And this is simple. I mean, it's your typical servo, right? So again, ground and 12 volts. We've already looked at the wiring up. So we've got our 5 to 7 volts in, a ground, and then the signal cable, we go to pin 6, and that's how we control the servo from the Arduino. So again, fairly straightforward on the wiring. The wireless radio, pretty straightforward. We've got, we've already talked about how the radio is wired into the 12 volts directly. the Arduino has the Ethernet shield, so we've got a Ethernet cable going to the network port and the Ethernet cable going to the network port on the Raspberry Pi. This radio has 2 Ethernet ports on it, so we just connect them both directly up so they can talk to each other through the radio. So if I close that out, here's our radio connection, our 2 Ethernet connections, and then our 12 volts coming in. And so that's our little radio. And I'll point out here's the other side of the control box. And so here's the Ethernet cable coming into the Raspberry Pi. I still had the Xbox controller plugged in when I took this picture. But underneath there is the Arduino cable, Ethernet cable coming in. The Arduino's underneath this. And so I 3D printed these brackets and cut the hole in the box. And so this Pi is actually sitting on a little 3D print I made that holds it above the Arduino. And again, I pointed this out last video, but this is just a terminal shield that sits on top of the Arduino and allows you to wire in the pins with little screw terminals. Again, I might be playing around with this project more, add some things, remove some things, test some things out. Just thought it would be fun to do that. So wanted a way to just quickly secure and remove connections. And then here was the relay trigger pin going to the Raspberry Pi to our GPIO expansion header. And of course, some of our regulators scattered around. And again, the 12 volt terminal block. There's where the 12 volt was coming in. So I think this pretty much wraps up the this video. Looks kind of, maybe not too neat in here. That I tried to keep it fairly neat, but pretty straightforward on how things are wired up. And then we'll get into the code and some of the other functions of things as we progress. So let me know what you think of this video. If you liked it, comment what your thoughts are, ideas, if you want to see more videos, and don't forget to subscribe. And that's it for this video.